Okay, let's start, and let's immediately have a look at the curriculum for Czech schools. And I have no possibilities to control, but you will probably recognize these things. I hope so. Please give me a word if not. So the 5th grade looks like this. It is about comparing numbers, rounding numbers, and so on. And I don't think I'm going to read all this. To go through the Czech curriculum, that's something you can do when you have time for it, and also maybe you probably have done. In arithmetic for the 5th grade, I want to focus those things that has a yellow color here, which is the multi-digit multiplication and the written multiplication below, and there was below 100, I think it says. I'm not sure of there is a word missing there. And also a multi-digit division, a little bit about fractions, about recognizing fractions, actually, when it comes to this age. And as you can see, I've also put a yellow color on units. And here it is measure units. We speak about measure of time, measure of length and weight, and also money, which is also kind of units. In the 6th grade, as you can see, I put the yellow color on the written division by a 2-digit number. And we are going to also go to, we are going to put put impact on fractions, on percent and decimal numbers. And I'm not sure that everything was yellowed here, because written division and also written multiplication below. I will give you some pictures on that. So that's the main topics that we are going to work with. And as you will recognize, those are parts that is in kind of, it has its place on this progression. These children, they have learned something before they arrive at these topics, and these topics will be kind of building bricks for further knowledge that they're going to also learn and develop in their future learning. I show you this as an example of materials that I strongly recommend to use. It is, as you can see, there are centimeter cubes. There are, I call them decimeter sticks. They are have 1 square centimeter in the end, and they are 10 centimeter or 1 decimeter of length. And here are also some, I call them decimeter squares. They are 1 decimeter in each direction. And finally, the cubes that are 1 decimeter each way. And you probably already know the reason why we can use this and what we can use it for, because we have a system of units and system in which we can work with concrete materials up to several thousands when we have such a material. Probably schools in Czech would have something like this. And hopefully they will have it in an amount that is enough for each kids to use their hands on and to calculate, not only in the brain and with the numbers on the paper, but to do it with real things. on their table. And you are nodding, Sylvia. I understand from that it's not that common to have these materials in Czech either, not in Norway either. But I really hope that somebody can change this, because it would be so helpful for all these kids who struggle, and not least for these children with ADHD who need to have accurate knowledge when they have so almost knowledge. And there is a lot of almost knowledge in mathematics for kids. They really, they know in a way, and they can manage to calculate and to use the calculation algorithms in a way, but like they are standing in a moor with not firm ground under the feet. And those kids with ADHD, they particularly need to stand on firm ground to be safe, because there are so many other things in their lives that kind of is not so stable in their emotions, in their ways of perceiving things, ways of managing, and so on. It goes together with those behavior criteria that constitutes the diagnosis. And we have to start with the units, the different units, because after all, what we tell always is units of one or the others. And it's easy to perceive this as a 1, isn't it? And if this is a 1, then we count it 1 at a time. And that's what we usually do when we are counting. We are counting 1 at a time. But of course, sometimes, and in particular, maybe when we exercise before the children are going to learn the multiplication table, then we also count like 2s and 3s and 4s and 5s and 10s. And 10s maybe first of all. And some kids, at least in some periods, like to exercise and count in 10s, even maybe before they've started schools. And parents applaud, of course. I think they're very good at it. And they are. It's good knowledge to carry and to use when you're going to learn more about it. So we can, when we have the unit 1, we can count 1s, and then we count 1 at a time. But we also speak about 10s. And what is what all 10s have in common is that they allow us to count 10 at a time. 10, 20, 30, 40, and so on. And these words are also constituted in a way that gives us an idea about what it is about. Not maybe 20. Actually, Nyborg, the professor, Norwegian professor I mentioned already, he recommended with children with problems, say 10 instead of 20, like the Korean, because then the words carry what this is about. I don't know whether it's a good idea or not. I've never really used it systematically, but when you work with children with special needs, it could be a good idea, actually. But then it will be necessary to bridge to the common language, of course, because that's how people are supposed to speak and how all the others will speak as well. So 1s, those we count 1 at a time, and 10s, those we count 10 at a time. And that's what they have in common. In other ways, they can be totally different in numerous less ways. And we also can make hundreds. And if we make them from the small centimeter cubes, we need a lot. And maybe we should not expect that the school has so many, at least for each child or each small group of children, but to have done this would be good, to my mind, for kids to really have seen that, okay, when we put them together like this as 100, okay, then we can also put a decimeter square on it. meaning that decimeter square we can use as 100. And that becomes much easier to work with than all these smaller cubes and a big number of them. And the thousands as well. And we can count with thousands at a time when we have something that is 1,000. And you can see it here, the cube, the decimeter cube. That equals in volume 1,000 of those small cubes, actually. And it is possible to try, but complicated with all those small cubes. So then we are at one of those issues that's listed in the curriculum for the math fifth in Czech curriculum. And you will recognize this kind of calculations. And I've shown on the picture here, I'm sorry, not all the texts here are translated, but the most important ones are, because in the first picture, it's obvious that there are 2 hundreds, 3 tens, and 5 ones. And there is 100, 8 tens, and 7 ones. And when we are going to calculate this, it is possible to do it with real things when we have such material. And the kids can see that, okay, this is reality. And to my mind, it's a very important point to help the children to tie their math knowledge in real things and in reality. And for most of us, that's what we need, math. And it's not wasted even for those who are going to study mathematics and be mathematicians or scientists in science, in math and chemical and physics and all these things, and work with math in more elaborated ways, of course. But most of us, we need mathematics to solve everyday life problems, to mind our economy, to make plans for our life when it comes to the bigger things that we need to buy, maybe a flat or a house, or we need to rent it, and that also have a cost, and we need to be able to evaluate our monies in that respect. And also, if we're going to buy a car, if we're going to travel or whatever, we need to know what it means in reality. And again, in particular, the children with ADHD, for them it's important to be able to really do it here and now. So what we do then is to put all these together, and we need to count all the ones. And when we have 5 ones and 7 ones, most of us adult teachers, we have automatized the sum of these 2 numbers. And we know that it makes 12, but let children find out. Let them count all these ones that they know have when they have these 2 numbers. And of course, one interesting thing then is it possible to make another 10? Yes, it is. You 12, you have another 10, and you have 2 ones. And you can use all those 10s that you have now to make new hundreds. And our system of writing this helps us keeping in mind what we have done. But if we don't do it, for the kids, these signs, like the one here, you probably have the same in the Czech ways of calculating. Or another way, maybe not exactly the same, but in some or another way, you mark and you remind yourself of that now we actually have made a new 10. And actually, now we have made a new 100 that we need also to count. And we need to count all the 10s and all the 100s. Yeah, this one came a little bit early here, I can see. It shouldn't have been there until we have counted all the 10s, of course. and see that there are 12 tens as well, and we get a number of hundreds. Also with the subtraction, and of course, this becomes more important the more complicated numbers we work with, and the more digit numbers we work with. And here, with only 2 digits, it's easier to do it just mentally without the concrete possibilities. But for some kids, that's really a requirement to be able to do it in reality. And one consequence of doing it in reality is that also this concept of units, ones, and tens becomes better learned. And the consequence of that again is that they are easier to activate when the situation are there for calculation, when you need to do it, either for a math task or for real life. So with the subtraction, and we are going to take out 25 here, but we don't have 5 ones, so we can't do it. And what we can do then, and you can see this, and you know this very well, and the kids you work with might know it as well, but those who need to do it with concrete things, please let them do it, and let them do it again and again, as long as they do. And I am totally sure of that the day they don't need it anymore, they won't do it. Because nobody flounder with this if they can just see what it is and write down the number and do it in the easy way. We in Norway, we do it like this. When we have made a new 10, no, excuse me, when we've taken a 10 and we have changed it with ones, and then we of course must take away this 10. And we make ones of it so that we can subtract the number of ones that the calculation here tells us to do. And we put this mark on the number symbolizing the tens, the number of tens, to remind ourselves that now I don't have 5 tens anymore, I just have 4. And again, I think probably you maybe don't do it exactly like this in Czech, but you know how they do it, and in some way or another, there will be some notations that means some of the same. Does it make sense? Maybe not a large number of those kids in 5th grade would need this, but this is possible to do also with younger children. And in my experience, and in the Norwegian curriculum, this comes earlier actually, with multiplication, no, not multiplication, with addition and subtraction, with 2-digit numbers at least, and also across tens. And this was exactly what she struggled with, the girl I told you about. And it was amazing to see how she managed to do this when she had something to work with. Knowledge and skills you recognize from what we did in the previous session, and I've decided to change the name to significant knowledge, because I'm not sure everything is listed here. There might be other important things too that nobody has thought about yet, but at least some significant knowledge in terms of concepts and conceptual systems are going to be listed here. And on the other hand, some skills that is related to multiplication. And to be able to present the necessary building blocks, and not literally with these materials, but the mental building blocks for the knowledge that the children are supposed to acquire. We need to think through these things. I don't know, I've seen some heard some say that in some countries, and Czech is one of those countries, it is very strict. We are going to work on these things and we are going to do it in these ways. And of course that could be demand and kind of literally a little bit too narrow jacket for a teacher to take on if you are not allowed to give the children also other conditions if that is helpful for them. Of course, if it is helpful for them. When you have a defined program, you have the school books and internet resources that helps you teach it, you don't need to do any analysis. You can just carry out this program. But you are stuck if any of the kids doesn't manage and doesn't succeed in their learning. So when we want to be teachers who can work flexible and help those children who struggle, we need to do this kind of analysis to be able to be flexible and to provide the helping aids that the particular child needs. Multiplication is a way of increasing the number of units. And if I stopped before, and if I said that multiplication is a way of increasing the number, then mathematicians would immediately raise their hand against me and say, no, that's not true. Because when you have units smaller than 1, that doesn't happen. Then the number becomes smaller. But when I add, I've made kind of secured my bet. We say, no, I don't know whether this is a saying in English actually, or in Czech. But I'm on more safe ground when I say not only the number, but the number of units. Because if we are clear about what units we are working with, the number of those units will always increase when we use multiplication. But of course, if we multiply halves or thirds, then we will get, and we have 6 halves, then the result of the multiplication will not be larger than 6. It will be, but it will be larger than the units, yeah, it will be larger than the unit we started with. That is a significant knowledge that we multiply to increase numbers. And if we want, we can also limit this to the whole numbers. Because then also, that's also another way of getting safe and not being addressed by somebody for telling lies. And another thing is that we can understand multiplication as a repeated addition. Multiplication can be used in other contexts, like those of combination, for example, but it can always be understood in terms of when we're going to find a number, in terms of repeated addition. And a lot of kids recognize that more or less by themselves. And that tells us something about that they are quite smart. And they relate to it. And of course, when a 5th grader or a 6th graders are asked, how did you do this? How did you do this calculation? Like 5 times 6. And the child tells us that, okay, I have this 5 on the dices, and then I think of it 5 times and I count 5, 10, 15, 20, 25, 30. Then we will think, okay, but we should maybe have automatized this and known that it is 30 just in the first place. But still, the child is quite smart, managing to count in this way and to understand, because that demonstrates an understanding of calculation. that is better, that we don't know about, I should rather say, when the child just gets the answer. And also significant knowledge is about the multiplication symbol, like all other symbols, as I mentioned before, like the numbers symbolizing the digits symbolizing numbers, and all the other symbols of operations in mathematics, and also about relations. And combined with this, we have the skills. And the little multiplication skill is mentioned in the Czech curriculum. Actually, I don't think any of these is mentioned in the curriculum. But I would provide arguments for that it is important still as a part of working with the multiplication skills and exercising and understanding the little multiplication table, so that you are not getting stuck if you don't remember the correct number combination. You can find out. And also all the multiplication algorithms, the ways of doing it when we're going to calculate with multiplication. And you can maybe recognize, even if some of you maybe have seen it just once, this triangle of what's our knowledge consists of: concept on the other, on one hand, skills on the other, and also some connections to emotions and motivation. And the art of teaching math is to teach both the concepts and the skills in a way that activates positive emotions, positive feelings in the child who's going to learn, who's learning. And also who speaks to the child's motives. And if the child's motive is, for example, to be good in math, everything that helps to understand and to help to automatize is answering that motivational need. You could say it like that. So all the feelings activated in the math learning situation will be a part of the luggage that the child carries on for further situations. And those same kinds of emotions and motivation will be activated in a situation that that is comparable, that is similar in one or another way. And of course, all math lessons, they are similar in some significant ways. So if you have very bad feelings in one math lessons, the risk for having the same type of feelings activated in another situation is quite big, actually. On the other hand, if good feelings are activated, the risk is maybe even bigger, at least as big, to have positive emotions activated in another math learning situation. So I'm going to demonstrate a little bit about this multiplication, how to learn the concepts. And the girl who asked me many, many years ago, when am I going to learn multiplication? That was a child that struggled a lot more than most children with ADHD do. She struggled with all types of learning, actually. And she performed as low in intelligence test, like 2 out of 1,000. So quite poor prerequisites for learning initially. But for her to learn concepts of this kind, those concepts that are a part of all our perception and necessary and helpful in all our perception of the world around us, the shapes, the colors, the sizes, the relations, and so on and so forth, is it that I'm speaking about. And she learned them, and she was able to generalize little by little, and that changed her learning history and her learning possibilities. But still, we it had never been discussed whether she should learn multiplication. But when she was in the 6th grade, one day she came into the lesson with a special pedagogue, which was me, And she asked, when am I going to learn multiplication? And what can you tell a girl? You can't say, no, that's nothing for you. I'm sorry. We must try. And it takes more than just using a math book. We need in such situations to know what concepts is it that is necessary to work on, and how can we do it. And multiplication as repeated addition was the concept that I managed to think of. And I tried, then I worked with the basic concept teaching for quite some years. So I was quite experienced. And that was very helpful, actually. And what we did was to look at numbers, real numbers of different kinds on the table, not only the materials I've already shown you. That's good for calculation, but it is not enough to learn the concepts so that the child can generalize and use them in new situations. So when we're going to learn the concepts, we need to do a lot of different materials. And multiplication as repeated addition means this simple thing: when all the sets have the similar number, we can multiply, and we can find a number in that way. And we have a lot of aids that can help us and check if that's correct. Of course, we can count. And when we start with small numbers, it's easy to count and find a number. And we can use a calculator, the electronic thing, and push the buttons and the multiplication sign. And we can see that the same number, 12, occurs there. And we can also have these written multiplication tables, and we can look and find 6 times 3, 3 times, no, excuse me, 3 times 4, 4 times 3. And we can see in both cases, the number is 12. Okay. Whatever we do, we find the number 12. Okay, but then we can use multiplication. And we can use multiplication because the number is the same. And that's kind of a feature of multiplication, that the number has to be the same. If the number isn't the same, we can't use repeated addition instead of multiplication, or we can't use actually multiplication instead of repeated addition. Repeated addition we can always use, whether the groups are similar in number or not. But we cannot use multiplication when the groups are not similar in number. But kids typically don't or do need more tasks. And look here, there are sets of balloons, and all these groups are similar in number, and we can check again if we want to, the number 3 in each, this time 2, and let's see how many groups, 1, 2, 3, 4, 5. So let's look up in the table or in the calculator, and let's count them, and we will again find the same. And we can use multiplication even when the number is not 3 in the groups. And we can try with, of course, different things with different sizes of the group, different numbers in the group. Whatever, we can use multiplication because the numbers are the same. And little by little, this will become the children's knowledge because they've experienced it in real life. And they have a totally different perception and knowledge about multiplication than those kids who just work with the numbers and manipulate all these numbers on the sheets of papers. But they need also, and what happens once the kid have experienced a couple of examples, the transfer starts. And children, like the girl I told you about here, she would not transfer as quickly as most other children's, because most other children's, they will be very quick in transferring into other situations, and they will not need that many examples. But let's look here. We have 4 groups of ducks, and we can see the characteristics of the number of ducks in the groups. And how could we make a calculation? Well, we could try the number 2 in each group, some 4 group. and let's try with the multiplication table, and let's try with the calculator, and let's count them and see. And what we will see is we don't get the same number. Here is something else, so we can't use the multiplication table and the multiplication type of calculation when the groups is like this. And look here. Here are two sets of groups, and they have the same type of figures. One of them is in an upright position, the other is in a lying position. And in which set of groups can you find the number by calculation? And that will be easy for the kids to see if they have done the previous steps. And it will be easy to pick out, and also easy to say, okay, in the group of the lying figures here, we can use calculation because it's the same number in the groups. All the groups are equal in numbers, or whatever way we express it. And here with some other just figures can also be with real things, of course, on the table. We do the same. But we need to discriminate and to demonstrate how, okay, if the number is not the same, then we cannot use multiplication. So now this is something different. Look here, we have a number of marbles. Find the number of marbles. And we have a number of oranges. Find the number of oranges. How are these two types similar? Okay, what is the meaning now? Well, they are similar in that the things that we count are round, but maybe that's not so important when we speak about multiplication. But are there other similarities? Marbles are in groups that are similar in numbers, so we can find the number by multiplying. The oranges are in groups also equal in numbers, so we can also use multiplication to find the number of oranges. Of course, that is quite complicated type of similarity, so the children need to be kind of having a culture of looking for this type of similarities through their previous experiences. This girl had. And here are two other tasks with the same characteristics, actually, but with other issues and other numbers, other figures and other numbers. This girl, she was, she calculation that was listed, kind of, this is a row of calculations with addition, with subtraction, and with easy multiplication. She was able to do when we had exercised in different ways, a lot of games, picking up a card with 5 times 8, for example, and matching it with another card that says 40, and so on, so that she had been exercising not only by writing calculations, but by a lot of other activities as well. And she knew a lot of the math, the multiplication combinations, but she, I was not sure whether she could use it for anything. So I was a little bit dizzy about the reasonability in doing this. So I had to check out for myself, does she really understand this? Can she use it for something? Will she be able to solve problems in this way? And then I gave her this task from the school book, and I have to admit that such problems, and even if this is a quite simple problem, I hadn't given her before, as we have been exercising all these several multiplication and tasks. So what she did was that she looked here, and she wrote all the numbers, and she knew the type of task, and so that was quite easy for her. But she arrived at 81 here, and there was an empty space, so she understood something is wrong, and she looked back and she thought a little bit, and she corrected herself. You can see the two kind of the reminders of, or reminiscences of the two behind there. She corrected herself and got it correct. And then she read the task here. And she was thinking for a couple of seconds. And she very quickly wrote the numbers over here. And she looked here and she wrote these numbers directly. I had to tell her, okay, I've never seen a kid doing this as quick and effective as you did now. This is marvelous. I couldn't really believe it. But it was, and she was really managing, and that was a lesson for me, actually. I was truly not sure of whether this was a point, but she convinced me by showing that this is some knowledge that I've got now, and I can use it to solve a problem in a very efficient way. So does it mean anything? If it means anything, it is a symbol. And the concept of symbols, I don't actually think that we can spend a lot of time on that now, because we need to do, but there is a book that's called Grunnlaget. I'm the author. I've written it in English, and Stefan, I don't know, Morten Heyer, Stefan Moravec, he has translated it to Czech. And this was in a project that we completed together with the organization People in Need, in Czech Republic, many years ago. This text, if you want it in Czech, you can send an email to post@pedverket. And you got an email from us today, and you can do it in that email. And we can provide it for you in PDF. It is also in English. It's available on our web page in English. And there you can find the whole set of tasks and ways of working with the concept of symbols to make it really a concept that the child can use flexibly. And if you have the possibility, even if you work with children in this 5th and 6th grade, to deviate a little bit from the school book, I would recommend just to do this and to try to find things functioning as a symbol for these the kids that you work with, like all the logos they relate to in their everyday life. Let me see, like all these, like the toys, for example, or the shops logos, like the different logos of music groups, of sport clubs, a lot of different things that has the function of being a symbol, and that we can use just to learn them that it is a symbol because it means something. And then they need to discriminate between what is a symbol and what is not a symbol, like the red color here. It doesn't have a meaning, but in the traffic light, it has a meaning. And which is a symbol? Is it a number 3? Or is it the tree? And where is the shape a symbol? Maybe you've noticed, and maybe you've learned even that all traffic signs that have a triangle shape, they means danger. So the shape is a symbol of something. Here, the shape does not have a meaning beyond itself. So look here, look at this logo and look at the red color. They are not similar, but is there a similarity? I think you know now. They are similar in being symbols, which is a great transfer, and it is a great, it speaks to this part of the brain, the executive functions, the planning, what is, which is big help for the children with ADHD. And maybe this is exactly the type of processing that they don't so easily, either arrive at such conclusions themselves. The bell has called, telling us that now it is half an hour break. Let me just look at that message.